Hi guys, today we will discuss about conventional string plus hash map, string plus sliding window pattern. So the problem name is minimum window substring. Means the name itself suggests or says that. So given as two strings S and T. So out of this, T will be the smallest string and S will be the largest string comparatively. So what we have to do is we have to find a range. In this we have to find a substring such that each and every character in T, A, B and C should be included. So in this case, by seeing visually, we can see if we take this entire string, it has A, B and C. But that is not the solution. We just have to optimize it. We have to find minimum window substring. So another option is this one, B, A and C. B, A and C. So in B, A and C we have B, we have A, we have C. So if you can observe, if you can see different iterations and check for the solution, this will be the ultimate final solution. So by seeing visually we can say, but if we get a very big string or if we get different strings, so at the time we need to get a optimized solution here. So two things here. One is brute force, conventional approach. Another one is optimized approach. So in brute force, what we will do is we will iterate this entire thing, and once again means how many strings in this particular thing are there. That many iterations we will do, and we will try to find out. So it will be 0 of n cube, O of n cube is the iteration, or in worst case it can be more than this. But in this optimized approach, we will use hash map plus sliding window. So by this approach, we can get the better complexity. So I'll tell a bit about sliding window approach. Means I'll give a rough idea. So sliding window approach means I'll take the same example, string S, which is A, D, O, B, E, B, A, N, C. So what sliding approach will do is, in our layman terms, it will take particular range. For example, first it will take only A. It will check. Means two things will be there in sliding approach, left sliding window and right. So initially we'll keep both left and right here only. So the substring will be A. So in this A, we don't have all these things. B and C are missing. So what we will do? The next option is to increase the range. So to increase the range, what we will do? I'll move right one step to the right. Means what we will do is we keep on incrementing right. So I'll move right to R. We didn't find all these characters. Once again I'll move it to here. Once again I'll move it to here. So if I take this ADOB, left is this and right is this. In this we have two things, A and B. So like this we keep on increasing. So you can see we can keep on increasing until ADOB, BA, NC. We found a range. So left is here and right is here. We found a range. But what we will do? We found a range. We found each and every character A, B, and C. But thing is, this is not optimized. So later on, what we will do? Once we found our required range and each and every character is present inside this, we'll keep on incrementing R. We'll try to decrease the range and check. So here, what I'll do? I'll keep on moving left to one step increment. So whenever I increment, A will go. So DO, BE, BA, and C. Here we have everything. A is there, B is there, C is there. So I'll once again, I can shorten it. I can shorten the range. So D, I move left from here to here. So O, B, E, B, A, N, C. So here also we have everything. B is there, A is there, C is there. Once again I'll shorten it. B, E, B, A, N, C. So here also everything is there. B is there, A is there, C is there. Once again I'll shorten it. E, B, A, N, C. This is there, this is there. Oh, sorry. My bad. B is there, A is there, C is there. Once again I'll shorten it. B, A, N, C. B is there, A is there, C is there. So at each and every stage, we'll try to store this particular string. Whichever string is having two conditions has to satisfy. The length of substring should be minimum length should pass, and another one is each and every character should present. So whenever these two conditions satisfy, we'll store left value, which can be start. I'll store start value and minimum length, because if I have start and minimum length, obviously in this string, let's say I start here and I have minimum length, then I can get this substring, right, with the help of those two values. So that's the thing. So after this, once again I'll try to decrease A and C, but here condition doesn't satisfy. It is minimum, but A is there, C is there, but B is not there. So condition does not satisfy here. So that is the thing. Sliding window is nothing but I'll keep some limits. I'll keep on increasing the right until I find the particular condition satisfied. Once the condition satisfies, I'll try to shorten the window, because in this particular window, if I shorten this, I may find the better solution, very short solution, because the condition is minimum here. According to condition, I'll find it. So it's basically nothing but according to the given condition, I am playing with left and right pointers, which are deciding the window. So this window keeps on sliding accordingly. So that's why it is called sliding window. So we can move into the pseudocode. First we'll see the pseudocode, later on we'll do the try run on the same example. Okay. So the pseudocode will be a bit complex, but if we keep our mind to it, it will be very easy. So it's basically simple. So I'll write PC, which denotes pseudocode. The first step will be edge case detection. So what I will write is, first point, if s dot length is less than t dot length. That means there are some particular cases in which these particular string length can be lesser than this. So if it is that, definitely that particular question will not have any solution, because if number of characters in the T string are greater than number of characters in S, obviously it's the solution will not be present in this particular S. Minimum window substring will not be present in S if this particular length is less than this particular length. So at that time we'll just simply return empty string, because we don't have any substring there. So I'll return empty string there. So the second step will be obviously create hash map. So that hash map, I'll denote it with a variable HM, or let's say for our convenience I'll keep it as just a map. So after creating map, what I will do is I'll iterate these particular T characters, means for char C in T dot to char array. So what I will do here is I'll keep in map each and every character with a frequency I'll keep in a map. Means map dot put, this step will be inside the loop, map dot put c comma map dot get or default c comma 0 plus 1. What this line says is, let's say a is there, I'll keep a as key, and value by default it will be 0 because we didn't have any a in the map. Initially the map is empty, right? So initially we don't have any map value, map key of a and related value, so we keep 0 but adding 1 because we are adding to map, its frequency is 1. If a repeats once again, so in the second time whenever we are pushing the a value, a key value paid to this particular map, at the time what it will do is it will fetch that particular value of key and add 1 to it. That means see, initially a I keep 1, so a repeats second time, what it will do, it will fetch 1 plus 1, that will become 2. So I'll just change the a value to 2 because a repeated 2 times. It's just nothing but counter of character, how many times it is getting repeated in the array. That is the logic here. So after that we will define some variables. So I'll define left initially equal to 0 and right equal to 0 and start equal to 0 and flag equal to 0 and minimum length should be max value and required. So required is map dot size and I missed something. Yeah, minimum length. Minimum length we will keep as max as possible initially because see, left and right we know, as we have discussed, these two are helpful in regulating the sliding window. Initially we keep both at the starting string. So start, why we are taking it separately means start keeps on changing, as I explained, A, D, O, B, E, B, A and C. So whenever left changes, the start cannot be at left always, because at this particular place left and right condition satisfies, later on left moves, but start stays here only. Start is setting, we are setting up start whenever it follows two conditions that we have already discussed. One thing is it should be the substring should be of minimum length, that is one condition. Another condition is each and every character should be presenting in that particular substring. So whenever that two conditions satisfies, we are setting up start. I mean, we are moving start. If that condition doesn't satisfies, we are not moving start. Same thing applies for this minimum length as well. That minimum length also we are changing it whenever it follows that two conditions only. So you will understand more clearly if we go into the pseudocode internally more deeply. So now what will happen is we'll iterate one more loop. Loop is a while loop, while right is less than s dot length, because I want my right to go until the end of this particular length of string s. Means right can go up to from A to C, it can go. So that's why I'm setting a condition here. So this condition is helpful in iterating right through each and every character index. Next we'll get particular character char, let's say this is the first step inside the loop, char c equal to s dot char at can be anything. It can be ranging from 0 to s dot length -1, because initially we have defined right as 0, right? That's why. So this is the thing. We got char C, means we will explain more deeply in the try run, but we are getting character at the particular index. Next, what I'm doing is window dot I missed one more point here. Create one more hash map window as well. These will be helpful in storing these mappings. So what I do, same thing as we have done here, map.put c comma map.get or default, this thing. Similarly, window dot put c comma map.get or default c comma 0 plus 1. So why we are doing this? Because the same thing, we are moving this into map in order to calculate the frequency of any repeated characters. Let's say A repeated 2 times here, B repeated 2 times here. In order to record all these observations, we are storing this into the map. That's the point. So the next step is condition. So the condition is if map contains C and window.getC is equal to map.getC, means it's very simple. We got this character C, right? We are checking if this C value is already present in map, means nothing but if this value, let's say we are at the first character A is present or not in this, and frequency of this A is equal to this frequency, means A repeated here 2 times. We are checking 2 conditions here, whether A is present in both or not, means which is equating, and second condition is the repetition, number of times it has appeared equal or not. So here A repeated 2 times, here A repeated 1 time. So I'll write the condition and explain it. If map dot contains key C and map dot get C equal to window dot get C. So this is the condition. Whenever this condition satisfies, what I will do is I'll add a flag. So inside this condition, increment the flag. So in this A case, it doesn't increment. Only in B case also, it doesn't increment. Only in case of C, means whenever we are at this particular index, C here in this string S, we have only one character C. In string T, we have only one character C. At that time, flag can be incremented. Until that, flag will be, however we have stated, it's 0 only initially. So the next step is we have one more condition, which is whenever this sliding window left and right is there, we have a condition to follow. Left should not cross this right and go here, means left should always be less than right, less than or equal to also. So that's the thing. So the condition will be while, because this is the condition which helps us to move whenever we reach particular solution. Later on, this condition, whatever while loop condition we are writing, this is helpful in optimizing that particular range. Means we have initially we got in this add-up bank can be also the answer, but we need minimum window substring. That's what condition we are adding here. If while left is less than or equal to right and flag is equal to required. Okay. So flag is equal to required. You understood this condition, left should not be less than or equal to right. Flag is equal to required means here A, B, C are there. A, B, C. Each is present one time only. So this frequency should match with this particular range. Means it is matching with B, A and C. Because here one time. But B, B, A and C if I take also, this cannot be the solution because B 2 times, A 1 time, C 1 time. So flag is not equal. In this case, flag is not equal to required. In this case, flag is equal to required. It is nothing but not only matching the characters whether they are present in or not, it is matching the frequency as well with the help of flag. So that's the point. So in this while loop, what we are doing exactly is I am calculating length. Means see, left is there, right is there. Between this, I want to know how much length. So the first point is if condition, if right minus left plus 1 is less than mean length, means it is nothing but this condition satisfies means we got a solution. But whatever solution we got, that particular range should be minimum, right? So this is the length of substring and this is the min length. Initially we are setting it to max value. So whatever comes first, it will be taken into min length. That's what condition we have written. So in this if condition, what we will do is, if this particular range is less than min length, then we are updating minimum length equal to right minus left plus 1. That is one step we are following. And one more thing we will be doing is, I will be moving start to left. Sorry, start is left. Because I tell you, two conditions has to satisfy. Initially at the starting of this video I told you, right, two conditions. One is it should be in the range, count also, frequencies also should match, that is one condition. And length should be, whatever range should be less than minimum length. Means it has to be the new optimized solution, then only the left gets updated, start gets updated with left. So coming out, we have one more thing to do in this while loop. I'll clear this out for you. So this is first point in while loop. I'm writing second point here. So the second step is I have to get one more character which is at left. So it's nothing but here we have given C right here. Okay, I'll change this. Char D, let's say S dot char at left. So why we are taking character at left? Because I want to know, I want to remove that in from the window, because whenever see, right is here, there is particular scenario, we found the solution, right is, left is here, right is here, but we are keep on optimizing, we are moving left from like this, we are keep on moving left. So whenever I move left, I have to delete these things. So if left comes here, I have to delete, means one previous thing, the one thing is at the left. See, I'm gonna move this left to here. Before moving it to here, before moving from A to D, I have to remove A. Later on I will move from the window map, because these things we are storing in the window, right? So I have to update the window, because I am changing the range here from L to R. I am changing the range. Every time I change the range, I don't want this to present in this. So what I will do, Third point will be that only. Window dot put d comma map dot get or default d comma 0 minus 1. So that's the thing. D comma 0, I mean not get or default, it is already definitely present, then only we can remove. So map dot get d minus 1. So that's the thing. So you understood why we are writing this third point, because I want to remove it whenever we are keep on going like this. So the next fourth step will be inside the while loop, means we are still inside the while loop only. We have to do one more thing, which is if map contains d, after removing also, if map contains d and the value d value inside window is equal to d value inside map, then we have to do flag minus minus. Why I am doing that means I removed this from the window. So even still after removing, the count is equal. I have to decrease the flag. Flag is nothing but the frequency count. So here flag we are doing this, right? We are doing this because whenever both for this character the frequencies and characters match, we are doing flag plus plus. But here whenever I remove, they doesn't match. So that's why condition will be if window dot get d contains d and map dot get d equal to window dot get d. So this is the condition. Sorry, not equal to, less. Means we have done remove this value, right? Means if map, whatever contains in the map doesn't, see in map the value is 2, window is map value is 1. So means here a is 2 times, but here a is only 1 time. So this is the case. Okay. So whenever this condition appears, I have to do flag minus minus, because flag is what represents occurrences. Later on, next step, what I have to do is I have to update the left and right. So internally, left keeps on changing, right? So this while loop still is there. So I have to close this while loop. What I will do is, fifth step, I do left plus plus, because this is responsible for keeping the while loop running. So whenever this condition is not satisfied, then while loop stops. So coming out, this is the last step. Coming out, I have to close this while loop as well. So in order to close this while loop, the point will be e, right plus plus, because same as previously, these right plus plus keeps this while loop running, and whenever this condition doesn't satisfy, this while loop stops. Later on, I have to return. The sixth step will be returning the string. So whenever returning also, based on condition, I will return. If minimum length is min length equal to integer dot max value, then I'll return empty string. Otherwise, I'll return s dot substring of start comma min length. start comma start plus min, because I'll tell you clearly what exactly happens here. Min length equal to integer dot max value, that is what we have defined here. So if this condition doesn't satisfy, then we didn't actually find the correct range. So if we didn't actually find the correct range, then we have to return empty string. So if it is not equal to this, then we do find the correct range. So what I have to do, I explained you previously with start and min length. So start will be this, end will be start plus min length, obviously, because start is this, the length, minimum length in the sense minimum window substrings length. So start is this, I'll get the end this by using both the boundaries, both the values, I mean indexes, which defines the range. S dot substring of start comma end. End is nothing but start plus min length. So this is the entire solution of minimum window substring. It may get complex when you don't know the correct approach, but if you can see, if you can divide it into sub-steps, if you see this particular part, you may see, you may feel little bit difficult for the first time, but it will be clear if you can divide it into steps and keep on exploring the logic. So for this, I think I have already explored dry run for this example. So what we will do is, I'll simply explain briefly. Initially left will be here, right will be here. Right keep on going until here, until this condition is satisfied. So after going that, after right goes there, what will happen is left keeps on moving each step until we found here minimum length. Then later also it will move, but we didn't find any solution because minimum length stays that only and start stays here only. Whenever left moves, start doesn't move. Start only getting updated when both of these conditions satisfies. So by that start and min length, we can return the solution. So that's it for today. Can stay tuned for more videos.